Now let's redo our calculations from a previous movie using the polar and rectangular features of the scientific calculator. In this way, we can check our answer quickly. Let's first remind ourselves about what we've seen in a previous movie about the calculator. When we use these features, we must measure the angle from the positive x round anti-clockwise. And we will find that the x components that lie to the right will be positive, to the left will be negative, and the y components that point upward will be positive, downward, negative. In a previous movie, we learned how to use the rectangular function on the scientific calculator. Rectangular coordinates mean x and y coordinates. So here we are finding the x and y coordinates of a 5 Newton vector acting at 70 degrees clockwise from the positive x. And how do we put that into our calculator? To get the rec open bracket, we press Shift Rec, which is the negative button. 5 is easy, of course. We have to separate the magnitude, 5 newtons, from the degrees, 70 in this case, by a comma. How do we get that comma? Shift open bracket. As you can see, there's a comma there just above the open bracket button in yellow. 70 is easy, close bracket, equals. So let's go back to the calculation which we've previously done in the long method, and now let's check our answer using these features. So remember, we have these two vectors and we are resolving each into their rectangular components. The 50 Newton to the right vector doesn't need any calculator to help us. There is only a horizontal component of 50 newtons to the right, positive 50 in other words, and the vertical component is 0 because it's not acting at all vertically. But let's turn our attention to this vector here. What are its horizontal and vertical components? What are its rectangular components? So we can see it on the Cartesian plane. We know that the y component is going to be negative and the x component also negative. We are given the angle between the two vectors, 140 degrees. But for the purposes of this feature on the calculator, we need to make use of the angle anti-clockwise from the x. Can you see what that angle must be? It's 360 minus 140. How do we get that? Obviously, a whole circle is 360. We know that this angle is 140 degrees. Take that 140 degrees away from the 360 and you have the angle that we're actually interested in, 220 degrees. The two together, 220 and 140, obviously make 360, a full circle. So we put this into our calculator. Rectangular component of 40 at an angle of 220. Remember, this angle here is 220 degrees, and that's the angle we put into the calculator, equals. That gives us an x component of negative 30,64. As we thought, the x component must be negative because it points to the left, and a y component of negative 25,71. As we thought, it must be negative since it points downward. So now we've found the horizontal and vertical components. We can then put that into our table. These are the values that we've just found. And you can look back to the previous video where we did it the long way using trig, and you will see that it's the same answer. Then the next step is to find the resultant of these vectors. So we add the horizontal components together, 50 minus 30,64, to find the resultant's horizontal component. And we add the vertical components together, 0 minus 25,71, to get the resultant's vertical component. So now we have the horizontal and vertical components of the resultant. How do we get the resultant? So previously we did this the long method. Remember, we move one vector so that we have tail, head, tail, head. We complete the triangle, and then we used Pythagoras to find the resultant, and we used tan to the minus 1 to find the angle. But now we can use the polar coordinate feature of the calculator to check our answer. So this is now not rectangular but polar coordinate. The polar coordinate function gives us the resultant's magnitude and angle when you have the resultant's x and y components. So what we need to have on the calculator is we need to have pole for polar coordinate. Then we need to list our x component first. In this case, positive, we don't need to write plus, it's obvious. We mean plus if we don't write it, so just 19.36, comma, and then the y component, minus 25,71. And then the answer we get is twofold. First, there's an r, and the r is the radius, in this case the resultant. 32,184, okay, we round it off to 32,18, and that is newtons in this particular case. So that's the magnitude of the resultant. And then it also gives us theta, and theta is always given in this notation relative to the positive x line. And here we have minus, meaning that it's going to go clockwise, not anti-clockwise. Anti-clockwise in this notation is taken as positive, clockwise as negative. Minus 53, meaning that the angle here is 53 degrees. So how do we get that on our calculator? First, how do we get the polar coordinate, POL, open bracket? We press shift and then the positive button. You can see just above the positive button in yellow it says POL. Polar coordinate. 19.36 is easy. Then we need the comma to separate the x from the y coordinate. How do we get the comma? Shift, close bracket. Because just above close bracket you can see there is a little yellow comma. Minus 25,71. We close our bracket and we press equal. And that gives us the resultant, in other words the polar coordinates, of x equal 19,36 and y equals minus 25,71. So here we have the x component of the resultant that we know, 19,36, and we have the y component also, which we know, minus 25,71, and we are finding these two values. That is what the display is going to give us. It's going to give us r, which is the resultant, and it's going to give us theta, which is to the positive x axis. So let me now do it on a calculator. Shift pole 19.36, shift close bracket to get the comma, minus 25.71 close bracket equals. We see on the display it shows 32.18 and so on, and it starts to show the theta value. You have to press the button to the right so that you can then see what is missing on the display. And we find theta equals minus 53.0197, so on. And that angle is anti-clockwise from the positive x-axis. So if we take away the minus, then it's clockwise. It means it's 53 degrees below the x-axis. So that's what minus 53 degrees means in this notation.